Hi, in this lecture, we'll talk about relational query languages. So there are procedural and there are non-procedural or declarative languages. In procedural languages, you define everything that you do step by step. For example, if I talk about making coffees, what are the steps to make a coffee? Uh, First, you take the coffee machine, you put water into the coffee machine, then you take the filter and you put coffee on the filter and you put the filter into the coffee machine. And then you have a jar where you take the coffee or a mug where you take the coffee and you then start brewing it. And that's how you get coffee. In this process, you declare step by step what needs to be done for you to get the coffee. That is procedural language. Relational algebra is a procedural language. And there are other languages like tuple relational calculus or domain relational calculus. Those are non-procedural. Imagine the same coffee example, but now instead of you making the coffee, you go to Starbucks and you ask for a coffee. You don't tell the Starbucks coffee barista that how to make the coffee. They do it themselves. You just care about the results. That means you only care about the coffee that you get. You don't tell them how much water they should take, how much milk they should take. Is it hot? Is it cold? You just define what the result that you want, and they are responsible for doing the steps and get you to the result. So above from these pure languages like relational algebra, tuple relational calculus, and domain relational calculus, these are all equivalent in computing power. But in this chapter, we will only talk about relational algebra. Relational algebra is not Turing machine equivalent and consists of 6 basic operations. What are the operations? Let's look into those. So there are 6 basic operations in relational algebra, that is select, project, union, set difference, Cartesian product, and rename. So the select operation. The select operation selects tuples that satisfy a given predicate. The notation is this mark over here. This is the select operation, and P is the predicate based on what conditions we do the selection. And then R, the small r is basically an instance. If we look into our previous lectures where we had the large R, that is the relation we define, and the small r's were the instance. Instance is at any given time, what are the data that the data table holds. Capital R or relation is basically the definition of the table, like what kind of attributes do we have in the table. That's basically capital R. And small r, that instance is at any given time, what are the data that table holds. So in the select operation, we select only at a given instance. Right now in the instructor table, select based on some condition. P is called the selection predicate. P is basically the condition based on which we do the selection. So example, select those tuples for the instructor relation where the instructor is the physics department. So if we look into the table of the instructor, here we have a lot of data in the instructor table, like ID, name, department name, salary, and there are lots of tuples. Like these are, each individual row is called a tuple. Now we want to select, so we write, can I do annotation here? Let me see. Hold on, just let me try annotating draw. So I can draw. Here. From here, if we say select, so what is the select symbol? This is the select symbol. And then we say that we need the condition. Condition is department name, where we want to select only those faculties or those instructors where the department is, for example, we want to say computer science. So select, this is hard to type over here like this. Let's, how do I erase this? Okay, text would be easier. Department name equals to com sci. This is how it is defined there. Okay, so if I do this, select where department name equals to computer science, and then from where we have to define that as well. So from, what is the table name? Instructor. So from instructor, that is the instance of this table. So what will this select operation pick? This select operation will, this is an instance of the table. The result will also be an instance of a table. Now we will see only those tuples where the computer science is the department name. So we will get 45565 cats computer science, and then 1010 Srinivasan computer science, and then 83821 branch computer science. So we will see only these three as the result. Similarly, they have an example from here. They selected based on physics department. They only got the 2 responses. If we had selected computer science, we would get more responses. Oh, I have removed the annotated. Clear all my drawings. Okay. Now, select operation is not only based on department name physics. We can have more conditions within this condition operation. We can allow comparison using equals, not equals, greater than, greater or equals, smaller than, smaller or equals in the selection predicate. We can combine several predicates into a larger predicate by using the combinations. This is and, or, and not. So find the instructors in physics with the salary greater than 90,000. We can write it, select department name equals to physics and salary is greater than 90,000 from the instructor table. This will give us only the results where they are from physics department and the salary is greater than 90,000. So if this is the table, we would get only one tuple, that is 2, 2, 2, 2. I understand physics 95,000. We wouldn't get the result like gold. So that would be not in that. If we run this select operation, we will only get one tuple. The select predicate may include comparisons between 2 attributes. Example, find all departments whose name is the same as their building name. So we can do is from the department table, let's say, now we are not selecting from the instructor table, we're selecting from the department table. Let's look at department table, how it was. Do we have a department table? No, we don't, but we have an example over here in department table. Here, department table. Department has department name, building, and budget. Now we want to select only those tuples where department name, in the department table, department name and building name is same. So for example, if we are located in Dowell Hall and our department is math, science, and technology, that would not show up in our result. We would only get if our department name is computer science and the building name is also computer science, then that would show up in the select operation. Now let's look into another operation, that is project operation, a unary operation that returns its argument relation with certain attributes left out. So for example, this is how projection is shown in the notation, and then attributes A1, A2, A3 to AK from the relation R or instance R, where A1, A2, AK are attribute names and R is the relation name. The result is defined as the relation of K columns obtained by erasing the columns that are not listed. Duplicate rows removed from results since relations are sets. So if we do a select operation, project operation, here we say project only ID, name, and salary. Do not show the department name. Example, eliminate the department attribute from the instructor. Then this data would show the resulting table. So we don't have the department name here, and because we only select projected the 3 of the columns. Where can we use this? This is used in multiple places. For example, even if you want to show the whole table to someone, you might have sensitive information. For example, you might have social security numbers that you don't want to show to other users. Or maybe, for example, if we talk about students, you want to see who your classmates are, and we show you that in a table, but we don't want you to see the grades or GPA of each individual student. So we do a project operation and we hide that CGPA or GPA from their table and show you only their contact information and their names in your class. So we use project operation in many cases where we want to show a part of the data, not the whole data, or we do projection based on our needs or the customer's needs. The result of a relational algebra operation is a relation. So if we do select operation or if we do a projection operation, it always gives us back another table from the original table. So the result is always a table. And if we have a table, we can do another kind of operation on that table. So here, when we did select department name equal to physics from the instructor table, this itself gave us a new table where we had only two tuples in that table where department name was physics. That's also a table. And on that table, we can do one more step and we can say from that table only project the names. So in this scenario, if we run this query, what would we get? We would get this same table, but now from this table, we did a project operation. So we would get something like, we did the project operation based on what values? Based on name only. So that we would get name, and then we'll get Einstein, EIN, and we would get cold. That's it. This is our new table. If we do a projection based on this table itself, so this is the table. For some reason, it's not going over there. Okay. Anyway, this bracket should cover the whole thing. I'm new to this, so or maybe delete this. Anyway, you get the gist. So from this table, if we do a projection, let's draw this, that would be easier. If I do a projection of name only, here we have name, we would get this table only from this table. So this operation, select operation, gives us this table, and from this table we should do projection only name, then we would get this table. So here in the instructor table, we say an example, eliminate the department name, and we get the department name eliminated. This is where we have, instead of giving the name of the relation as the argument of the projection operation, we give an expression that evaluates to a relation. So here, project name, instead of giving the table name, we gave another expression that gives us the table itself, not the name. Let's look at our Cartesian product operation. The Cartesian product operation denoted by X allows us to combine information from any two relations. So we have different tables and we want to combine those tables to see some data. We can see that using Cartesian product. The example, Cartesian product of the relations instructor and teachers as written as instructor X teachers. So this will come instructor table and teachers table. It will combine both of them and give us one single table. We construct a tuple of the result out of each possible pair of tuples, one from the instructor relation and one from the teacher's relation. See next slide. So in the next slide, we will see for instructor table, one instructor might teach multiple courses. So we create tuples for all the possible combination. That instructor teaches 5 courses, then we will have 5 tuples in that table where the instructor name will be same, but the teachers will be different courses. If we look here the instructor is Srinivasan, and Srinivasan instructor ID and teacher's ID is same. So based on that, we know this is the same person from computer science. and he teaches multiple courses: CS 101, CS 315, CS 347. So, and Fin 201, MU 199, and Physics 101. These are all the courses that he teaches. Um, and the instructor, his name is Srinivasan. Here, we have to match the instructor ID and teacher's ID. Based on that, we have this information. Since the instructor ID appears in both relations, we distinguish them where attributes are attaching to the attribute name of the relation from which the attribute originally came. Instructor ID and teacher's ID. We will combine these two and see the actual data. So here, if these three rows where Srinivasan, instructor ID, and teacher's ID isn't matching, that means this is not a valid column or tuple. This is not a valid tuple. This is not a valid tuple. Even for this one, if you see from finance department teaches CS 101, this is not going to make sense because the instructor ID and teacher's ID isn't going to be same. That means in Cartesian product, for each pair of instructor and teachers, we have multiple data. So for each pair, we have this matching, and then from this, we select only those where instructor ID and teacher's ID is same. Only then we will get the original data. Otherwise, Srinivasan doesn't teach MU 199 or Physics 101 because the teacher's ID and the instructor ID does not match. It has to match. So for that reason, we use join operation. The Cartesian product instructor X teachers associates every tuple of instructor with every tuple of teachers. Most of the resulting rows have information about instructors who did not teach a particular course. Here, Srinivasan didn't teach MU 199. Mozart didn't teach CS 345. Einstein didn't teach CS 315 or Fin 201. So because the instructor ID and the teacher's ID doesn't match. So we have lots of data that doesn't make sense. Like most of the resulting rows have information about instructors who did not teach a particular course. To get only those tuples of instructor X teachers that pertain to instructor and the courses they taught, we select only those. So we have the Cartesian product. This gives us this whole big table. But from this table, we only select where instructor ID equals to teacher's ID. So that is basically saying select instructor.id equals to teachers.id. So from the whole Cartesian product table, we only get only those tuples where that instructor actually teaches that course. We get only those tuples of the instructor as teachers that pertain to instructors and the course that they taught. The result of this expression shown in the next slide. So here it is, where instructor X teaches. This now makes more sense because Srinivasan teaches ID as instructor ID matches, and these are the only course that they teach. Here 1 2 1 2 1 1 2 1 2 1. So we know now who teaches Fin 201, Mozart teaches MU 199, Einstein teaches Physics 101. So these IDs match, and this table makes more sense because we did the select operation on the Cartesian product. Cartesian product gave us a lot of data that didn't make sense, but we did the select operation where instructor ID and teacher's ID is same, and then this table makes operation. This is join operation. So today's class is up to this. Next class, we will look into all other operations that we can do in relational algebra.